We want to look at the integral of the form. I have two forms here. The first form is where I'm dividing the derivative with its original function. And the second form is where I'm multiplying the derivative with its original form. So I have two forms that I want to look at, and I have the two examples. So I'll start with our first example, 2x plus 3 divided by x squared all over x squared plus 3x. So in the first form, I let u is equals to x squared plus 3x. Then I have du over dx is equals to 2x plus 3. And therefore, I make dx the subject of the formula. And that's what I get. And that's what I get from that. Now I go to the original equation, substitute in the values. And therefore, that's what I get. I get 2x plus 3. Instead of writing x squared plus 3x, I put u. And instead of dx, I put 2 du over 2x plus 3. And this will cancel out. And what I'll be left with is du over u. What is the integral of du over u? If we ask ourselves, and that gives me ln of u plus c. And therefore, what was my x? What was my u? It was x squared plus 3x, and then plus a constant. Remember, we always put a constant of integration whenever we are dealing with indefinite integrals. The second form of equation that I have is the integral of sine x times cos x dx. How do I approach this? The approach is almost similar, just slightly different, where I let u is equals to sine x. So then I get the first derivative. What is du dx of that? And we know that the first derivative of sine x is cos x. So du dx is equals cos x. If I make dx the subject of the formula, it will be du over cos x. Now, let me go back to the function and write it down. So I substitute back sine x. And I know what is the value of sine x. Instead of writing sine x, I know I'm going to write u. And then I'm going to put cos x. Instead of dx, I write du over cos x. And again, those two cancels. And I'll be left with an integral of u du. And what does that give me? And that goes up to u squared over 2 plus c. And I know what is u is sine. That's so I can write it as a half sine squared x, sine x squared plus c. And that definitely gives us the solution to the two integrals. So you can review that and you realize that it's very easy to integrate such types of equations of this form that you have looked at today. And thank you for watching this video, and I hope you've enjoyed.